Hi! So today we are going to be talking about test-driven development and what it is and what is it for. So traditionally when we write code, pretty much what we do is that we write our functions, we write the implementations for those functions, and then we write the test in order to verify that those functions are working correctly. So the problem with doing that is that we are already biased because we already know what the functions look like and what the implementation looks like. So we are going to most likely write the test in order to pass the already implemented code. So test-driven development asks us to invert that. So the first thing we should do is write the tests that are very closely to the requirements, and then we should implement the code that complies and pretty much passes those tests. So TDD, or test-driven development, come with three phases. So the red phase, green phase, and refactor phase are three different steps that you're going to face constantly during the test-driven development. So the red phase is the first step you have to do, and pretty much is when you create your function, you can create your signature functions, right? But then before creating the implementation of the code itself, you go ahead and write the testing for that function. And it's called red because, of course, if you write your test before your actual implementation, is going to fail, right? So that's the reason why it's called red. Now, the second phase is when you write your implementation and the implementation works as expected. So that's green when the test passes. Now, you should not try to write the most performant or the best code in the first attempt. It can be very difficult, or it can be very, it's not a good practice, right? So the third step is the refactor. So the refactor is when you have to go back and then modify the code, write it more elegant, or maybe use better implementations. And then the advantage of doing these is that since your tests are already passing, you can verify that the refactor that you are doing is not making your implementation break, is not going to be disruptive with your already testing code. So let me write a very quick example here. So I have here with my calculator service, which is an empty function I have right here. Sorry, an empty class I have right here. And then I have a test for this. So I'm going to be using just JUnit. I am not going to be using any injection framework for this. So let's say that I want to have, I don't know, let me say a function that just adds two numbers, right? Very simple. So I could create, for example, the number A and number B. Right? Now I want the result to be to call the myCalculatorSaves function that I'm going to write. So myCalculatorSave is that sum, right? And then I'm going to pass number A and then number B, right? So this function does not exist yet. So I'm going just to ask my IDE to create that. And so far, what I'm going to do is make it return 0, right? Oopsie. Perfect. So now, of course, that is not a correct implementation, but that's fine so far. We are still in the red phase, or we haven't arrived our red phase just yet. We are just creating the signatures. Now, in the test, I'm going to have to write test for my sum. So let me create a couple. So let me create missed test methods. So this is going to be the scenario 1. Right, and then I'm going to do, for example, number A is equals to 10, and then number B is equals to 100. So the expected result is 110, and then the actual result is equals to call the myCalculatorSaves sum, and then pass number A and number B. Now, of course, I have to assert. So let's assert that the expected result is equals to the actual result. Perfect. Now, let me create another scenario just to make sure that everything is fine. right? So I have the scenario 2, where actually number A is -10. So the actual result is going to be 90, right? Let me just write a last scenario, third scenario, where number A is, I don't know, -10, and then this is going to be -15, so the result is -25. Perfect. Now, if I run all the tests on this function, on this class actually, they are going to fail, of course, right? And the reason for that is that the assertion is failing on each scenario. The reason for that is that this function, it's returning 0, not the actual sum. So what I could do now is go ahead and do the implementation. I could just do number A and number B. Perfect. And then since I already wrote the implementation for this, I'm going to run again the tests. And these tests are now going to be positive. So now I am on phase green, right? Because the functions properly passed. Now, let's say that, for example, and this is just a very, very quick example, let's say that I don't want to use this implementation because maybe I am not using the best method. This is just an example, right? But maybe you identify some pieces of your code that you say this could be different, this could be better, maybe I could use a different data structure, so on, I don't know, right? So I could say, for example, oh, okay, I want to, instead of doing this, I want to do math.addExact and then number A and then number B, right? And I want to see if that actually is going to be correct. So I can go ahead and run the function, and there you go. This works, and this could be a better implementation of the code I wrote, right? So pretty much what this allows me to do is to be able to refactor my code and make sure that my code is not going to change its behavior based on the implementation I am doing. So now here I can make sure that result it's going to be exactly what I needed. So there you go, 25. Very good, exactly the number I needed. So that's pretty much it. That's a quick introduction to test-driven development. This is going to be a cycle that it's going to repeat once and again during your development, but it's going to provide your code with some resiliency and predictability. So thank you so much for watching, and see you around.